All right, today is week 3, day 3. We're gonna go over this morning's algorithm. I think this is a fun one, but before I do that, let me introduce some concepts here. All right, so up until now, we've been using var as a way to declare variables. We've said var this is a number, or var that is a string. And it's a good way to teach how to use variables because it has that word var, you know it's a variable. But var is mostly unused when you're writing JavaScript. There's a couple different ways to declare a variable that we'll be going over. And the difference between how var and how these variables are used, I'll go over the most fundamental difference, but it's going to dive into this concept of scope. And I don't want to introduce scope right away. I could, but I don't want, it's not necessary for this for today's algorithm. So I'll try to just keep things as minimal as possible for now. Okay, so I will introduce these different variables. They're called const and let. And then we'll also be going how to write an if-else statement in a new way. Okay, so let and const declarations can only be accessed within the block that they are declared. So a block is that area in the function. So if I say const, function example, okay, this area from 8 to 6, that is a block. Okay, so let and const declarations can only be accessed within the block that they are declared. So have that in mind whenever you're using them. Okay, so what is const? Const cannot be updated or redeclared. So when we say something is constant, we're saying it's constant. It cannot be updated or redeclared. So if we declare a variable with const, we can't do this. Const greeting equals say hi, and then we say greeting equals now say hello instead. There's going to be an error. We can't reassign a value to const. It's like once you put something in that box is full of glue. So it's going to stay in there. It's going to be constant. Okay. The opposite would be for let. Okay, let can be updated, but not redeclared. Okay, unlike var, a let variable cannot be redeclared within its scope, that area, that block area. So while this will work, let greeting equals say hi, greeting, excuse me, greeting equals say hello instead, this will say an error. Okay, so let greeting say hi, and then you can say let greeting equals say hello instead. But however, if the same variable is defined in different scopes, there will be no error. So here is it declared at the top above the function, let greeting equals say hi. So if something is true, let's say it is, then let greeting say hello instead. And now if we console log greeting, it's going to say hello instead. It's the typical way we've been using variable. But let is a more common way to use it because variable, that var keyword is globally scoped. So don't worry about what that means yet. Just know that this is going to be the way we'll be declaring a variable that will change now. Okay. So const can't change, let will change if you redeclare it in a different scope. Okay. How well are we understanding this from 1 to 10? I'll go over it again here.
I
So
think you need to go over the scope for let.
well, that's going to be maybe another lesson. So maybe I'll do arrow function and scope. But
Hey, Josh, I
yes,
think my big point of confusion is the line that constant cannot be updated.
okay.
And the function that you made for yesterday's array sets a constant variable and then updates it later in the code.
Okay, I'll take a look into that
It
function.
worked when I ran it on VS Code, so that's confusing to me.
Okay. Well, let's look into that. But for now, we are saying cannot be updated or redeclared.
I don't know if this is going to be confusing or help or not, but a constant array or function is a constant pointer to the or reference to the variable, so the contents can change, but the actual variable, the object or the array cannot. So it can't point to a new array or a new object. So that's what's constant, not the contents inside.
So the contents, it could be like pushed or popped or like
Right.
that.
Yeah,
but
the
like
physical
array itself can't be changed.
right. That when you do
You
a
can't assign it to a different array.
right. Not to try to complicate it, but
It's a subtle difference, and we'll learn this. It's not huge to today's. It's not super important to today's algorithm. I'm just lightly introducing it, and we'll get more familiar with it over time. So it's okay if it's a little confusing for now. Just know that this is generally how it should be understood.
And then when you're saying, sorry, Josh,
go ahead.
When you're saying scope, are you just talking about the content in between the coding blocks?
The scope has to do with where the variable can be accessed from.
Okay.
And
so
yes, it has to. Yes,
Okay,
it has to do with the within the blocks as well.
Okay.
Yes.
Okay. Is that every situation? I kind of feel like you were hinting at maybe that's not with every situation.
Wait. Well, are you asking for let or for const?
Well, I'm just saying scope. When you're saying scope, I'm like saying, are you always talking about the content in between the coding blocks or no?
No. I'm scope. It has to do with the range at which we can reach a variable.
Okay.
Sometimes can have to do with the coding blocks. Sometimes can have to do with the JavaScript page itself.
Oh, okay. Oh, I got you.
So there's something called the global scope, and then there's the function scope. So the without getting so abstract and complex, we'll just say for now this scope here, this function has access to this let variable, let greeting equals say hi, so that we can change let in this function here, just like we've been using var. Okay, maybe I should do an official lesson on this, but I'm thinking how I would do that without stepping on the toes of the JavaScript instructor later on. But anyways, you guys should be able to work with this just the same in today's algorithm. Okay, so let and const. Different is const can't be changed, let can be changed within here. The value that it equals here can be changed within this scope.
I mean, scope is just where the variable actually exists, whether it's inside a function or outside a function. But I was going to comment, why does lines 26, 27 get an error? Because it's let and then it's getting reassigned. That wouldn't be an error, would it?
It's being redeclared within its scope.
Yeah.
So if it exists in this type of scope, it should work just fine. Where it's outside the function.
Isn't it saying on 24, this will work? And then the error is coming from 30 and 31 saying,
Oh, well,
because you're
yeah,
redeclaring
I
greeting.
think I read that wrong. I pulled a
But yeah, so like 26, if 27 had let greeting, yada yada yada, that would be an error. But 26 and then 27 without the let, that wouldn't be an error.
Because you're not redeclaring.
Yeah,
Yeah.
I think I'm reading my own notes wrong here. Okay, so let's reiterate over this. Unlike var, a let variable cannot be redeclared within its scope. So this will work. Okay, we can redefine the contents in the variable here. This will return an error. We're redeclaring this variable within the same scope. We're saying let greeting, and then we're saying let greeting again. This is just reassigning the values in greeting.
Josh,
Yes.
on line 33, if we get rid of let and just put a greeting equal to say hello instead, it gonna work or not?
On line which one?
33.
33?
Uh-huh.
Yes.
Oh, okay.
Yes.
Yeah, I was kind of confused. Okay.
Yes.
We cannot put let twice. Okay.
Right. Cannot
Okay.
put let twice within the same scope.
Thank you.
It's a good question. Sorry, I misread it wrong, and I even threw myself off while I was explaining. I thought, okay. Sorry about that. Let me reiterate. This is declaring the variable, and this is reassigning the value. This is redeclaring the variable twice here. Okay. Now, also, I want to show you guys how to write an if-else statement in a new way. Okay. For now, we've been saying if true, do this, else do this instead. Okay, but there is a shorter way to write it that you can even incorporate it into a return. So here it is. We are going to say let stoplight equal green. Okay, so stoplight equals green. And this here, from this question mark to this, this check is asking, is stoplight equal to red? That question mark is the if statement part. If so, then stop. And this colon is the else. Else, go. So this is an if-else statement.
Can you use this notation for if else's as well? Like up to as many as you want?
Not as many as you want. I think it goes up to 3.
Okay, so if you have a bunch of if else statements, you're gonna need to use the full handwriting.
Right.
Okay.
Yes. Yeah, it goes up to about 3 else's here. So stoplight, is it equal to red? If so, then stop. Else, go. So how well are we understanding this new if else statement from 1 to 10 here? Okay, cool. All right, so today's algorithm is not going to have to do with arrays. There's nothing that is way out there that you know, a JavaScript tool that we haven't introduced yet, but it is going to require some thought. And I've done most of the algorithm for you guys, so it's going to be maybe a fun puzzle. I'm going to find out. We'll find out together. Okay. So has anyone heard about the Fibonacci sequence? Anyone
Yeah.
know what it is?
Yeah.
They had something similar with the Fibonacci part of the array challenges on the Learn platform here.
Okay. Yeah, there's definitely some Fibonacci questions in the algorithm book, and it's a fun algorithm. Sometimes interviewers will throw it will throw this at you. I've had a friend that they asked him, hey, can you write this function? And he wasn't familiar with it, or he couldn't remember. So it's good to know. Okay, and it's a fun algorithm. So here's what the sequence is. All right, so we take 0 and 1 and we add them together and we get the next number in the sequence. 0 plus 1 equals 1. 1 plus 1 is equal to 2. And then we say 1 plus 2 is equal to 3. So we get the next number in the sequence by adding the last 2 digits in the array up to that point. 2 plus 3 equals 5, 3 plus 5 equals 8, 5 plus 8 is 13, and so on. Okay, so that is because 0 plus 1 equals 1, and 1 plus 1 equals 2, and 1 plus 2 equals 3, and 2 plus 3 equals 5, and so on. So does everyone understand this one? Can we get a status check 1 through 10, how well we understand how this sequence builds? Cool. So we're going to write a function that I'm going to say, what is the 5th number in the Fibonacci? I'm going to say, yeah, what is the 5th number in the sequence? And you should be able to write a function that will say 0, 1, 2, 3. So 1, 2, 3, 4, 5. It's going to be 3. I'll say, what is the 3rd number in the sequence? If I give you a 3 to your function, you should return the number appropriate. So let's read the directions. The Fibonacci sequence is defined as follows. The first number of the sequence is 0. The second number is 1. And the nth number is the sum of n minus 1, n is n minus 1th and n minus 2th numbers. I don't know how to pronounce that. Write a function that takes in an integer n and returns the nth Fibonacci number. Okay, the Fibonacci sequence is often defined with its first 2 numbers as f0 equals 0 and f1 equals 1. For the purpose of this question, the first Fibonacci number is f0. Okay, therefore get nth fib1 is equal to f0. So if I say, give me the first number, we're returning 0. Get nth fib2 is equal to f1. So we're going to return 1. Okay. For the purpose of this question, if I ask you for what's the first number, you're going to return 0. If I ask you for the second number, you're going to return a 1.
So can I ask a question quick?
Yes, please.
So do we just, so the way I'm thinking about doing this is making in a function to make the Fibonacci and then making a separate function to get that, or do you want it to be all combined, like make it and get the indice at the same?
I'm going to give you guys most of the algorithm here, and
Oh, okay, cool.
I'm going to see if maybe it'll be super easy, maybe it'll not be able to be solved at all. I'm sort of testing alongside with you guys here, trying to figure this out, how well this is able to be figured out. Okay, so I'm going to write this function. I'm declaring this function get nth fib, and it will you put n here in the parameters, and we'll say const last two equals 0 and 1. Okay, we'll start with that, and then we'll let a counter equal 3. Counter will be something that you add to. It's going to count something. You're going to add to it, so it's going to be counting whatever you add to it. Then I want you to do something in here, okay? From line 89 to 91. If I see that it's too difficult, then I'll give you guys another hint. I think this will be enough. You want to do something in here, having these pieces already. And then I want you to consider this return statement. So the return is going to say, is saying, is n equal to 1? Is it greater than 1? Then give me last two at 1. Else, give me last two at 0. If it's greater than 1. Okay. If it's not greater than 1, then give me last two at 0. That's because in that case, it would be the number 1 that we're giving. So if we give the number 1, then it's going to say return last two at 0.
Can we get are we gonna have a copy of our directions here?
Yeah, I'm sending everything.
Cool.
Okay. So I'll be hopping between rooms and just watching you guys to see if I need to give you guys more hints. Okay, so I'll paste this into the Discord. I'll assign you guys to rooms as well.
Line number 92, please.
92?
Yeah.
So
yeah.
what this is saying is I want you, it's asking for a return, and it's saying an if-else statement in the return itself. Okay, I'm saying here, return n if it's greater than 1, then it will be last two at 1. Else, the value of n is going to be the last two at 0. What is last two at 0? It's 0.
So you're either returning last two at 1 or last two at 0, depending on the value of n.
Right.
You're not returning n.
Right.
Okay.
You're asking here, you're either returning last two at 1 or last two at 0, but I'm asking, is n greater than 1?
Mm-hmm.
That's the if statement. If that's true, then return last two at 1, else return last two at 0.
Can I see line 55 again? When you're done.
Say that again.
I just want to see line 55 again when you're done explaining this.
Line 55?
Or up a little bit more. Yeah, 55. Okay. I just want to see what that
I'll send this as well.
Okay.
How about I send everything here?
I think that's a hint.
Hey, Josh,
Yes.
I don't understand why we don't want to return I thought we were trying to make a function that gives us the value in the Fibonacci array at the index of n.
Right. Yeah.
Yeah,
Right.
that would make more sense.
So if I give you n at the value of 1, we're
It
going
would
to ask
return
here,
1.
is n greater than 1? No, right?
Right.
So we're going to trigger this else statement. It's going to say last two at 0, return last two at 0. So we look into our variable last two, and its position is its value is 0. So that is what we're returning at 1.
But won't this only ever return the first two values of the Fibonacci sequence?
Right. So we're going to have to figure out how to change its values here within another scope. So we're going to be using something here to change these and use this counter as well. We may have to change this counter in the area that we do something here.
Oh.
Okay.
Glad it's clicking for you, Spencer. I understand what you're saying, Josh. You want us to change the digits in last two to be in this wherever we're ending up with the Fibonacci.
Yeah. We're not building out a giant array of Fibonacci numbers. We're changing an array of 2 digits to be the latest of the 2 Fibonacci numbers.
Right.
Okay. I'm
That's
giving
a
too much
challenge.
hints. Now when it starts clicking, I'm like, did I do the whole thing for you guys?
No, I still don't even know where to start. So we'll that's good.
Okay. All right, I'll post this in the Discord. And then I'll assign you guys to groups here. Okay, posted it. And I'll start assigning you guys here.
Just start recording while we talk gibberish.
Okay. Hey, we're back. Let's get this algo explained. So would someone like to present?
Someone was.
I didn't realize I was.
But we shied away. So let's get the question.
We can present. I'll present.
Okay, thank you, Evan.
Yeah, volunteered yourself for tribute.
I did, not even intentionally. I didn't understand how that happened, but that's fine. That's fine. Now it's volunteer. All right, can you see this? Yeah, you can. Okay, good. So yeah, what we're doing, instead of making a whole Fibonacci array and producing it in a like where it's everything. I'm gonna get rid of that. This is just an array that does that, makes it up to 50. We are changing the insides here to match that sequence in the array. So we've got counter set to 3, which is at first the equivalent of saying n is greater or equal than last two length plus 1, because we're trying to go this way with it. So yeah, so in the example here, let's put 5. And we're going to get back. I have a console logging the actual array after we've changed it. And the way we've changed it is with a temp variable. And we've set it equal to last two indices of 0. And then we change the last two indices of 0 to equal 1, which is shifting it this way. And then we are changing this one here, the indice of 1, to be temp plus 1. So it's just continually adding for as long as number is larger than or equal to counter, and it's adding counter as well. So when I go through, initially 5 is greater than counter. So then you add a counter and counter, and eventually it'll get counter will equal 5. If I didn't have this equal here, it would go up to 4, and we would get this one, the one before. But we didn't want to do that, so we added the equal there. Yeah.
Okay. So let's try and T-diagram this. I'm going to try to T-diagram this for those that may not be understanding. So let me share my screen here. This will be good practice for me. Okay. So I gave you guys this code. I wanted you to do something here. The key was writing a while loop. So we say while counter is less than or equal to n, I would create my temp variable. So this, well, I don't have to create it called temp. I'll say const, we'll say the next number in the Fibonacci sequence is going to equal last two.
I can't use
at 0 plus last two at 1. Then we'll say last two at 0 equals last two at 1, last two at 1 equals next fib. And then we increase the counter. Okay. So the way the sequence increases is by adding the two first integers. We have 0 and 1. So 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 3 is 5. 3 plus 5 is 8. Okay. So that's why we had the counter start at 3, because this is position 1 as far as n is concerned. Okay. N is at 1. It's going to be, the value is going to be 0. When n is at 2, the value is going to be 1. And so 3 would be outside of this sequence, outside of this array. So we said counter, let it equal 3 to be the outside, because we already accounted for the first two. If we said if it's greater than 1, and that would be 2, then we say last two at 1, which is this 1. Else, if it's not greater than 1, which is it would be 1 in that case, then last two at 0. Okay, if it would have been 0, if n would have been 0, then we would have still got last two at 0. But in any case, we said the next Fibonacci sequence is going to be the last two at 0 plus last two at 1. And then we say last two at 0 is going to be last two at 1. So we shift it over, the value's over. So now 1 would be in the place where 0 is. And then we say last two at 1, whatever is here now, is going to equal to the two positions added. And then we increase the counter And this is going to run while the counter is less than or equal to n. So if n is a really high number, we're going to keep adding to the counter, keep adding to the counter. So let's try and T-diagram this now. I'll do my best here not to screw up. So let's see. Oh, and I'm already flipping around here. Maybe red? No, my marker doesn't want to work here. Oh, I can't annotate. So I guess I'll have to write a T-diagram like this. How about this? Var and val. So we have our variable. Let's say we give get nth fib. Let's say we give it 5. So our first value will be n. And the value is going to be 5. Ooh, what if I did this? There, now we have a T. N is equal to 5. Okay. And we have last two. Push this over. So we have last two at 0 and 1. We have counter. And counter is 3. And so we said while counter is less than or equal to n. So 3 is less than n, which is 5. So then we enter this while loop. We say const next fib. So we create a new variable in here, say next fib. We make it equal to last two at 0 plus last two at 1. So last two at 0 is 0. And last two at 1 is 1. So then 0 plus 1 is 1. And so we say last two at 0 is equal to 1. So let's make a new value. Last two at 0 is 1. And then we say last two at 1 equals next fib. So next fib is 1. Okay. So then here we are again. Last two at 0 is 1. Last two at 1 is equal to next fib. Okay. And then we increase our counter. Now counter is going to be 4. And while counter is less than or equal to n, so counter is 4, it's less than 5, so then we enter this while loop. And we say const next fib equals last two at 0 plus last two at 1. So last two at 0 is 1. Last two at 1 is 1. So then we say next fib is 2. Okay. And so now we say last two at 0 is equal to last two at 1. So let's write this again. Last two at 0 is equal to last two at 1. So the 0 position is equal to the 1 position. So we say 1. And last two at 1, whatever would go in this position here, is equal to next fib. Next fib is 2. Okay. And now we increase counter again. Counter is now 5. While counter is less than or equal to n, it does trigger because it's equal to n. 5 is equal to 5. So then we enter again. And we say const next fib is equal to last two at 0 plus last two at 1. So last two at 0 is 1 plus last two at 1 is 2. So then we get 3 as the value for next fib. And we say last two at 0 now is equal to last two at 1. So we shift 2 over to where 1 is. And we say last two at 1 equals to next fib. What is next fib? It's 3. And then we increase counter again, counter plus plus. So now it will be 6. And so here we say counter is not less than or equal to n. So we exit this while loop. And so then we return n. So we say return n if it's greater than 1. Is n greater than 1? Yes. Oops. So then we trigger this here. Last two at 1. So now we go to last two at position 1. It's 3. So we're returning 3 now. So let's check here. If we count here, 1, 2, 3, 4, 5, we've got it. If we enter in 5, we should get 3 in the return. If I did a good job explaining, let me know. Give me a 1 through 10. If not, give me an honest feedback so I know what I can do better. I think this is easier than using the pen. Cool. Okay, I don't see everyone's names here, but maybe hopefully I did explain it better. Okay, so that ends today's morning algo session. Unless we have any questions, does anyone have any questions?
I did mine in a different sort of way. I want to know if it was okay. It's kind of broken. It kind of works.
Okay, let's see it. Share your screen.
So I did it like recursively.
Okay.
Mm.
Sometimes it gets I looked up like the 11th index and it gets that right. 89 or 1 puts out 1. Sometimes it, but at like the 5th index, it breaks. It says the 5th in Fibonacci value is 5, even though it's not. But it continues to output Fibonacci numbers.
It just breaks at 5.
Yeah. Or 6 too, apparently. And I want to know if there's a way to fix that.
Okay, so let's read it. We have last 2 at 0 and 1. We have the counter. We never use the counter. So we say if n is greater than 2, return get nth fib at n minus 1. So in this case, n minus 1 is 5 plus n minus 2. So you're saying 5 plus 4. So if n is greater than 2, you're getting 5 plus 4, which is 9, right?
Yeah.
Is that what we're returning in that case?
I don't know what we would be returning. I'm pretty sure we'd have to go through the loop again to determine what it's returning.
Yeah,
Like it has to go.
let's run it. So with 6, what is the value going to be?
Let's see. It hasn't stopped running the program.
Yeah, I was just gonna say, are you doing that recursively? Yeah, it looks like you
Yeah.
are. So it's just probably taking a really long time, to be honest with you. It does not take long, even with something this simple, for it to just like, even after 5 iterations, it's so many operations. I remember going over this in Spencer's class the one time where we were doing this exact same thing with trying to get the Fibonacci sequence, and as soon as we exceeded like 7, ish iterate like in the recursive calls, it would break. He let it go for like 30 minutes and it still didn't finish, so we just up on it. But I feel like it was a bigger number than 6, though. I don't know.
So for those wondering, a recursive function is one that calls itself within itself. And sometimes you can, oh, there it goes. Is that the answer, 89?
Yeah.
Yeah, so that's not really working.
There
is a way
breaking. Your function doesn't have anything happen when n is equal to 2.
Yeah, I was just messing around with that. It's supposed to just be a basic return function. And I guess I was trying to make sure it doesn't catch on anything here, but that does make sense that it's not doing anything here.
What you could do is say if n is equal to 2, return 1. And then you could say, so write that if n is equal to 2, return 1. Right, because at the second one we're getting 1, and else if n is equal to 1, return 0. And then outside this if else, then we say return get nth fib at n minus 1 plus get nth fib at n minus 2. Okay, let's delete the bottom and yeah, let's delete the counter at 21 as well. And you don't even need the last 2 either. This is just an if else.
Where?
Yeah.
Oh, up here?
Yeah.
That's the right answer. I just typed in 11 to test it last time.
Okay, cool.
55.
Okay,
All
we
right.
didn't really go over recursion, but this is how you would do it recursively. It's actually not as efficient as the answer that we
Came up
used the
with.
while loop. Yeah.
Okay, thank you.
But this is how you would do that. Cool.
It's like 55 squared or whatever operations that way, or 55 factorial, because you're making like, you know, 2 operations, and then those 2 operations make 2 operations, and those 2 operations, every one of those make 2, so it just keeps like doubling every time. So I guess it would be exponential.
Okay.
Would it
Yeah,
be
that's
n to the n?
Yeah. N squared.
so we'll go over, you guys will go over that in the JavaScript stack, in the MERN stack. But for now, let's end the lecture here. That's how you do the function if you called it within itself. But I'm glad you guys were able to solve it or understand it. Okay. Cool. Let's go ahead and take a 15-minute break, and then we'll do our stand-ups, and then you guys are on to your own projects.